Hello, my name is Kostas and I work as the technical artist teacher at the Game Assembly in Malmö, Sweden. This video is part of a larger series of videos called Getting Started with ShaderFX for Maya, and in this video I'll show you how to do animation using a vertex shader. So the heart you see in front of you is from a user on Sketchfab called Dark Lord Flash. And I'm also using an HDR probe from Playback, which I use as a cube map for my lighting and the reflections. So I'll be using the interactive playback just to demo this. Now that's under the FX module and fields and solvers and interactive playback. The reason I'm doing that is because I wanted to showcase the locator I have here as well. The locator will, as I move it around, it will change where the point of the animation starts. You'll see that the origin seems to stems from here. And as I move it over here, it goes outwards here, etc. So I'll place that back in the middle of the heart again. I've also got a few parameters over here, such as speed, where I could, for instance, say speed up the animation of the heartbeat. I've got one called distance impact. If I set that to 0, you'll see that the entire heart will expand and contract every point at the same time. But just with some offset, you get that delay where it's expanded here and it'll take a fraction of a second for it to expand over here, or a few fractions. There's the pump exponent. With that value I can make the contraction more forceful. So right now it's following more of a sine wave where it's both soft when it expands and contracts. And as I increase this one, the contraction will feel more forceful. The movement distance is basically just to set how much it will expand and contract. The animation center, as the category name here suggests, is actually just connecting this locator to the shader. So these are yellow because I've connected the transformation of the locator to these exposed shader input parameters. And visuals is purely just for the visuals of the heart, so it doesn't actually relate to the animation itself. So I'll start with just opening the ShaderFX shader, and I will do this from the scratch, and I'll show you every step of the way. But I did not want to reinvent the wheel, so I stuck with the traditional game surface shader that you get by default. All of this is just for the visuals of the heart, so I won't be going through that. But the input pin here on the material node, which is called object vertex position, that's what I play around with to animate the heart. So everything up here is for the animation of the heart. And with most of the time when you just want to modify the vertex positions of the object, and you usually want to base it off the original positions to begin with, you need this node, which is the vertex row position. And if I were to just plug that in, I would see no change to the heart. That's actually the default value I get if I don't connect this at all, if I just have this unconnected. So if I just start with this and then add something here, that should give me some form of displacement or movement or whatever you plug in from here. So to do this, I think I'll just go ahead and delete all of these. And let's start from beginning. We'll take it step by step. So I will enable advanced mode to be able to access all nodes here. I'll grab that node again, which is called vertex world position. And if I then just grab an add node, let's add a value here. Let's grab a float 3, for instance, like so, and let's add it over here. Then if we select this one and just minimize, we could try just playing around with moving these values and see what that does. So if I set these back to 0, you'll see that I now take the original vertex position of the heart and then I add 0 to each dimension. So basically it will sit at its original position. But as I increase this value, for instance, for each vertex point, it'll take the mesh, the stored mesh position and add 2 to the y value. So it will seem as if I'm moving the entire heart upwards. So obviously that seems to work as intended, that I can affect the vertex position. So Next thing we could try is we could try using time. Time is the node in ShaderFX that you can use to drive animation. Time will output values which correspond to seconds in Maya. So depending on how you've got your scene set up, if it's at 24 or 60 or 30 frames per second or whatever, it's going to take that long for this one to output 1, 2, 3, 4, etc. Now, usually, depending on what type of animation you do, at least what I'm used to when it comes to vertex animations, you want to make some form of looping animation. And to loop this value, you would usually use, there are a few alternatives, but you could use fractional, for instance, which is, as the thumbnail suggests, it'll only keep the decimal part, the fraction part of a number, which means that as this is ever growing, it'll just keep the fractional part, which will pretty much equate to a value going between 0.0 to 1.0. I think technically it never hits 1.0, but 0.99999. But you could think of it as 0 to 1, and then it instantly drops down to 0, and then up to 1, instantly down to 0, etc. Oh, I forgot to say, but in order for this to play, to see some form of animation out in the viewport, you need to hit the play button or the interactive playback. Yeah, that is a requirement for this one to actually output to get any update here. So this could be an option. You can use the Modulus Node, this one, which will do something similar. So if I input this here, and then I could use a float node, for instance. The float node I would plug in here, and then if I set this number to say 4, for instance, this one will only ever now go between 0 to 4. As this value is ever growing, and since I set the second value here to 4, this one will go from 0 to 4, and then it'll drop down, and then 0 to 4, and drop down, and 0 to 4. But if you need 0 to 1, this will do essentially the same thing. And the other quite common option is to use a sine wave, which is what I'm going to use in this case. Sine wave is basically, you plug this in here and you get this type of motion, where it's constantly going like this. And actually, to be correct, a sine wave goes from +1 to -1. So +1, -1. And keeps doing that. Even as I zoom out here, you'll see that even as the x-axis, which represents time in my case, since I'm feeding time into the sine wave, even as that is ever growing, the sine wave will only ever go from +1 to -1 and keep repeating that pattern. And this works quite nice for a heart animation. Straight out of the box, it will seem very constant in terms of speed, or very smooth, and that's why I wanted to make the contraction more forceful, and I'll get to that later. But I think this is a good start for the heart animation. So we could just try using this value. So I could, for instance, just force this one to take in a float value, and then we could try just plugging this in and see what that does. And as I hit play, you now get this type of animation. So since it's basically adding 1 into each of the axes, you get this kind of diagonal movement here. So this is when the sine wave is at +1, and then it cycles to -1, +1, -1. And it's not that fast currently either, it's fairly slow. So the other thing we want to do, we don't want the entire heart to move like this, right? We want it to seemingly expand or contract. And the way you usually do that to get that kind of inflating looking movement is that you move each vertex point here by its own individual normal direction. So to get that normal direction, we search for vertex and world normal. So with the world normal, this here value will output the normal for us, and that is going to be the movement we want to move the vertex in, either that or the inverted normal to make it contract. So if I were to just to showcase what it looks like, if I delete this one again, and I would need to force this one back to a float 3, so either disconnect the pins or do as I just did, or create a new add node. But if I add this here, you'll see that the heart is now severely expanded. You can see that it's expanded to the degree where these veins or arteries, or what's the correct terminology, they've expanded so much that they intersect into each other. But this is the type of movement we want. Instead of the heart just going diagonally like this, we want it to expand like this, or inflate. But it's doing it way too much, right? So in order to tone down on the actual amount of distance it moves, we could add a multiplied node in between here. So if I plug this in here, we take this value and we can set that to 1.0 to begin with. Plug that in there, you should see no difference. But then if I just try playing around with setting this value to something lower, you'll see that it's not expanding as much, right? If I set it to minus 0.5, it should contract. It's even contracting, collapsing into itself in these thinner parts. But for now, let's start with just seeing what happens if I plug this in here. So now I should be able to hit the play button and get that same type of motion. Yep, so that's definitely start. You can see that this is starting to move towards the result I showed you earlier. But there's definitely some tweaks you want to do. I'd say looking at it, we want to be able to tweak its speed, the amount of distance it actually inflates and contracts, and a few other ideas as well. But let's start with that. So in order to set speed, you can basically just multiply at this end to make the time go slower or faster. We just multiply. So before it goes into the sine up, we do this. And this is definitely one of those values that I'd want to be able to access from outside of the ShaderFX interface. So I'm going to use this as an exposed float value. And I'll call this speed. And input that in here. Plug this in here. Now as I click here to have nothing selected, you see that I can access speed here. And if I set this to 5, for instance, and I hit play, it's moving a lot faster, which is good. We can control it from here now. Right, and the other one was that we want to be able to set the amount of distance it actually expands and contracts. And that amount actually stems from these values. So these values represent a normal direction, but in this case, the way I'm using them, they actually also represent a positional offset. So same logic here, we can use a multiplied node here to be able to set the movement distance. So I can just probably grab these from here, copy paste, and move them down here. And this won't allow me to connect here, right? So I could tell ShaderFX that I want you to accept a float 3 by just typing in 3 float values and pretty much forcing it to reassign to float 3. Plug that in here, this one in here, and this one could be called movement offset or distance. I'll go for offset. So let's see what that does. So movement offset 5 would be crazy much. Yep. So 0.5 perhaps. Yep, that's better. If I set the speed up to say something like this. Yep. Right, so another thing which strikes me now is that this is looking fairly in the direction I want. This is moving way too much. And one way to actually resolve that is that we could use a vertex color set, which is what I did for my example. You could possibly use some kind of procedural logic or distance from some point or something to make these expand or contract less. But if we want to give the user some form of control to be able to more specifically say this gets not much and this gets much, etc., we could use vertex painting. So to be able to just showcase the color, I'll switch to Lambert 1, like so. And here's my vertex coloring. So I've assigned a new vertex color set. I'll just show you that so you see it. It's under, let's see, do I see mesh display in here? Yes, mesh display and color set editor. So there's a color set called color set 1, capital S with a humpback style. And I've just used the red channel, and I've painted more bright red where I want to have more effective animation, and darker red even almost towards black where I want less of it. So I could use this as another multiplier just to set the weight of how much it can move at certain points. So color set 1, to remember that name, I'll assign this shader back to ShaderFX. And then to be able to access a vertex color set, I'll just move this, give myself some more space. I'll type vertex, and I've got vertex color down here. Make sure you grab this one on the input comments, or not this one. I'm not entirely sure what this one does or how it works, but I want this one. I think actually this one is a part of the group here, which is called vertex color. It's a bit confusing. But you want the one under input comments if you don't want to recreate all this group logic. And to be able to access the vertex color set I just showed you, I need to input the color set name here. Might be able to use the index, but I prefer to use this one. And if you drag from this one, you'll see that it's a string, and the V indicates that it's a string value. So if I search for string, you want the string value one, not this one. String value, let's connect that one. And on the string value node itself, in the value parameter, you need to type the name of the vertex color set. That was color set 1, like so. And remember, I told you that I painted in the red channel, so this one should give me values between 0.0 and 1.0, I think, since I have a normalized vertex color set, or a clamped one that goes between 0 to 1, I think. So at this point, we could just add that in the chain here, which sets the amount of offset. So I think I should be good with multiplying either here, here, or here, since all of these are just multiplications going on, or at least there will be 2 of them. The order of the multiplications doesn't really matter. So I could set it over here, for instance. Copy this one, connect that one over here, the red one over here. Let's move this to the side so it flows from left to right. And then this one over here. And let's have a look and see what that does. So you see now these don't collapse on themselves anymore. And I have less actual movement here and more over here. That's what I achieved with my hand-painted vertex color set. So next thing I could try to go through here is to set the offset of time here to not have it expanding and contracting at the very same time all over the heart. And the way that is done, if you remember, I had a locator. You don't need to use a locator, but the idea here is that we set a specific point, and then for whatever point is being rendered or sampled, you check the distance. Say that I'm over here, you check the distance from here to here, and you use that distance as a time offset. So the time is always going to be quickest here, and then you allow an offset. The further away you get, the more offset it is, so it will be delayed, if you will. So to be able to do that, to be able to get that length, we need 2 positional values. One is going to be this fixed value, and the other one is going to be for the sample point, grab the vertex position information for that point. Then we compare those. So if we want to expand on this and have the locator that you can update, the way you connect the locator to the shader is you'll need to have some exposed parameter on the shader itself, like these values, which you can actually connect the locator to. Now, since we want to grab the locator's transform data or translation data, the position, you would think that a float 3 would be a nice idea because you have XYZ position. But ShaderFX sadly does not allow you to expose float 3 variables. So if I type float 3, I've mentioned this in a prior video, but if I place that over here, there's no expose feature here. So I'll need to use a regular float, which has expose, and then I'll have to have 3 of these and combine them together to build my own float 3. So if I grab 3 of these, such, I'll label this one position X or pos X, pos Y, and pos Z. These all need to be exposed. If I want my interface a bit more nice and tidy, I could use a UI group. So animation center point, for instance. Copy paste that in here and in here. They wouldn't show up in the interface yet. They'll need to be connected somehow and contribute to this network before you'll actually see them in the interface. So next thing is, remember, I want to have these as a float 3, so I want to be combining these. So vector construct, x to x, and y to y, and z to z. And I can grab the float 3 from here. So we've now got the locator point, the fixed point. The other point is going to be for my sampled vertex, or may it be pixel, but it should be vertex since it's a vertex shader. I want to grab that positional value. That one is called vertex world position. So this one. And now, to get the length of these, you take one and subtract it by the other. So subtract. So. And then there's actually a node called length, which will calculate the length of a vector here. So if I do this, I'll get a float value which, just as the thumbnail shows you, it gets the length of that vector. This should actually be exactly what I need to be able to use it as a time offset. Shouldn't be more difficult than that. So what we want to do now, as I mentioned, this is going to be an offset for time, and I've got time over here. I basically take my time and I subtract by this amount. And likely this amount is too much. I'll want to have a way to set how much effect this actually has. So if I need to subtract by time, let's move my time over here. Let's grab a subtract node. So subtract, we'll take time minus this amount. We could have a look at what this looks like. It'll probably not look nice at all, but before I throw a multiplier in there, let's see what this looks like. So there's way too much time offset now. So in here we need to throw in a multiplier. So I could grab something like this, save myself some time from actually finding the nodes, and connect here, connect here, and we'll call this one time distance time offset, for instance. And remember, when this one was plugged directly, it was way too much, so this will want to have a value way below 1. If I uncheck here, so nothing's selected, I've got my distance time offset, and since it needed to be lower than 1, let's try a tenth of the amount we had before. Here we go. Starting to look more like we want. And let's try 0.5, for instance, half of what we have. I think that looks pretty good. At least we could leave it at that for now. If we wanted to try playing around with actually connecting the locator, you would need to select your locator, go to Windows, General Editors, and Connection Editor. You could do this in the node editor or any other editor that allows you to connect nodes. But now I've got my locator 1 out here on output, and on input I need to get my shader. So select your model, go to the shader tab and hit select. Once you've got the shader selected, click reload right. The shader should show up here, and here's our exposed values. So first we need to find the output of the locator that we want to use. That's going to be my translate. And then I need to grab each of these individually and say translate is going to feed into position X, Y to Y, and Z to Z. And you see that these now turn yellow. This means, let's try using the objective playback again, that I should now be able to select this one and move it around, and it should update this on the fly. So you can see that it now seems to stem from that point. All right. So next part we want to look into is, I think, getting that more forceful contraction. And the way you do that is, or at least the way I did, is I used Desmos. I like the Desmos or any other calculating software interface that allows you to just play around with inputting values and plotting out the graphs to see the effect of that. So I realized that, okay, in order to get this more forceful, and on the contraction side, the contraction is going to be when it comes from the high point to the low point. And one way when you have a value change where you go from 1 to 0 or 0 to 1, you can use the power of feature. So I tried grabbing my already existing curve and just using a power of and increasing that value, which makes the value change drop a lot faster. So I realized that this might work, but I'd need to find a way to make sure that I only grab from the blue graph when the value is dropping here, and then when it's expanding, I want to follow the red graph. So it should go red, 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 and then here hit blue and keep blue all the way over here, and then go red. But before I did that, I realized that I wanted to normalize the range first, because if I wanted to use the power of feature, I'd need to make sure that the sinus output I got was going from 0 to 1. So I can show you what would happen if I did not. If I just close the visibility on these for now, and I use, let's say, b equals sine x. And then if I tried grabbing b and using that power of 2, for instance, or 5 or something like this, 4, you see that I get this kind of interesting result depending on if I have an even or an odd number. It starts to get quite weird. And I did not want to handle this case, so I figured, okay, let's see if we can get the output of the sinus to instead of going between -1 to 1, what about if I shift it to go from 0 to 1? That would mean that the heart would keep its original shape and only ever expand and then contract back to that shape. I figure that might look nice as well. That might be a change I want either way. So in order to do that, to shift this from -1, it is at -1 to 1, and shift it to 0 to 1, you can, for instance, multiply by 0.5 and add 0.5. That change will now move the negative point up here. So I wanted to shift this. So if I go back here, let's do that. And here's my output of my sine wave. So to give myself some more space between here, I'll move this a bit. And I'll use a multiply node. And remember, I wanted to multiply by half. So I can type that in directly here. And then I wanted to add a half. That in here. And before I continue with the showing you what I did in Desmos, let's just have a look and see what this looks like. So there should be a visual change now, because the heart should only go from its original shape and only expand outwards and back to the original one. And at this point, you might want to play around with, time and a bit of speed, and just to give you a feel for this. At least I'd want to gauge if is this a change I'd want, or would I want to retain the other one. And I think actually this looks better than when it contracted, when it became smaller than its original shape before. I think it got too small. I think it looked a bit odd, so I do like this better. So I'm going to go ahead and keep that change since it looks better, and it also works in favor of doing this kind of math calculation. So now if I show you the power of feature, I should now be able to set whatever power of exponent I want here, and it shouldn't start doing some odd stuff as it did when I fed negative values in there. Right, so as I mentioned, I've now got this, and I wanted it to start with the blue one and shift to the green one when it goes downwards. So one other thing I realized that as I move this upwards like this, the starting point, the 0 point here, did not correlate nicely with this point here or this point here. Before I did this, it was crossing here, and that felt like a pretty okay starting point since it was at 0. But I think it's much more easier to grasp, and especially for the next step, if we can just make sure that this is our starting point, or perhaps this one. But I do prefer this to have no change in the beginning. So in order to get this over here, I should be able to use, if you look at the distance between here to here, that should be, if I'm not mistaken, 2 pi. And I think from low point to high point is 1 pi. So if I just type plus and then pi as in pi, was not correct, so maybe I'm mistaken. It might be that it's pi, maybe plus pi divided by 2. Yes, but likely minus, since I wanted it to, yes, that's better. This is what I wanted. Actually, what happened if I did a minus pi? Just curious. Yes, okay. Pi divided by 2 minus pi divided by 2. That actually shifts the value so that this is now my new starting point at 0. Great. And this one, since this is derived of this one, would also follow along. Perfect. So I felt that I had two outputs that I knew I wanted to use now. So now I only needed to find one way of shifting between these. And I tend to think of it as creating and manipulating a mask where I have either black or white result, or it could be in between as well. But I'd want to have a result where it's, say that it was either black or white all the way to this point, and then as it hits this point, it should flip up and be something like this till it reaches this point and then down again. So sort of like this is what the result I'd want. And notice now it's a bit easier to see, but if I click over here, you'll see that this is 1 pi of distance. So from here to here is 1 pi distance, 3.14. And then to get over here, it's 2 pi. So there's 3.14 and then 6.28 over here. All right. So what I wanted to do now is I wanted to use the Modulus node to start with. So if I type modulus and then x is what I want to have my growing value here, and then let's try with pi to begin with. I get something like this, which is a pretty good start, because by using pi here, since I know that's the distance, you'll see that this one is going to go over here and then snap down here. And that's almost in line with what I want. But remember, I wanted it to go all the way over here before looping. So it's actually pi times 2. I'll show you where I'm going with this. So pi times 2, this one reaches 6.28, both in y and down here. So now this is the full length of one cycle of sinus wave. So that's good. So now I should be able to manipulate this to make it look like so. And then as it hits here, it's just going to loop its behavior. Right. There's a floor node, which is really useful. So if I try showing you what floor does, it's going to do this. Floor throws away the fractional part or the decimal part. So it only keeps the integer part. So that's why I have 1, and then there's no in between. There's no gradual growing. It just keeps 1 until it hits 1 point something, and then it snaps up to 1 here. Or sorry, keeps 0, and then as it hits 1 point something, it goes to 1, snaps up to 2. This is the type of behavior I want, but I'd want this one to retain all the way to 3.14 and then snap up to 1, retain all the way to 6.28, and then loop the behavior. So in order to do that, I just basically need to scale down this value. So this one is way down here instead. And the way I do that is, before doing my floor modifier, I should be able to divide by I think is the correct amount actually, as such. So see how this now goes 0 all the way over here, and then goes 1 all the way over here, and then loops the behavior. And if you think of this as a mask, I have black all the way over here, and then white all the way over here. And with that output, I should be able to use that as a way of saying use one source, use the other source. I can remove the floor here again just to showcase what this looks like without the floor. So if I do this, and I think I lost my divide in here somewhere. Divide by pi, like so. So I have a value going from 0. It hits 1 exactly here, and then continues up to 2 over here. It just reaches 2 at the very end. And since I'm flooring, any value below 1, which is my entire distance here, will be rounded down, and any value here below 2 will be rounded down. So that's why a floor gave me this kind of operation. Without the divide of pi, we had looked at this before, but I had this where it went to 6.28. If I divide by 6.28 is 2 times pi, and if I divide by pi, I'll be left with 2, right? So it reaches 2 at the maximum point. So divide by pi, and then wrap this in a floor operation again to round it down. So floor, such. Perfect. So let's see. I shifted this. We did that in ShaderFX. We shifted to a 0 to 1 output. We haven't yet offset by minus pi divided by 2. Before I go ahead and do that, if you just have a look at this, I have the same kind of thing up here. But I'm using pi quite a lot. I've got pi divided by 2. I've got pi multiplied by 2, and I've got pi here. And instead of trying to recalculate the division here and the multiplication and the division in ShaderFX, I could just pre-calculate this and use it as 3 different constants in ShaderFX. So in ShaderFX, I want to have one constant which represents pi divided by 2, one constant which represents pi times 2, and one constant which is just pi. So I'll start with just asking Google equals pi, and I have this value. I should be able to copy that. I've had some issue with actually copy pasting values between ShaderFX, so let's see if it's going to work out for me or not today. I grab a float. I think I might have nailed it down, but I'm not able to paste in the property panel interface, but I do believe I should be able to paste in the attribute editor. So with some luck, if I select this, hit Control V and enter, yes, that worked fine. I'll type pi. We now got pi. We want pi divided by 2. So, and if I type pi divided by 2 and copy paste this value and select that value and input it into the attribute editor, Control V, it's to work fine. And then we wanted pi multiplied by 2 as well. So change that character. So the pi multiplied by 2. Let's grab that value as well. Paste it in the attribute editor. Yes. All right, perfect. So back to translating this here into ShaderFX. So let's start with just doing this. That is the value I feed into my sine wave. That is before it's being normalized or shifted into 0-1 range. So before, the value I feed into sine should have minus half a pi before it goes into the sine. So sine wave is over here. Here's the value I feed in, so I should take minus half a pi. So let's give myself some more space. That over so. Grab a subtract node since I have one floating around, but since I have one, I can just steal it from there. Plug that in here. Remember, order is important here. It should be this is my first input and the half of pi is the second input. So this one, plug that in there and replace the previous value. So all that should do is actually just shift the result of the sinus to the right so that this one hits the 0 mark. I want the result of my pi equation, and that is after I've normalized it. I want that result and then raise it to the power of 5, for instance, in this case, or whatever the user prefers. So here's the sine, here's the multiply by 0.5 and add 0.5. So here I want to have a power node. Power is the power of. And I plug that in here. I grab another float. I think I want to expose this for the user to play around with. So I'll plug that in here, expose this one, and I'll call this one contraction power exponent. It's a long term, but contraction power exponent. It's exposed. So this is my unmodified output, and this is my modified. So this is for when it's expanding, and this is for when it's contracting. And I now need to construct this. So that is modulus x, and x in this case is the same as the x I feed into here. So that was my modified time before I do minus half a pi. So that's the same x I want to use here with a modulus, and the other input of the modulus should be pi times 2. So that x I refer to is, remember we just did the subtractant with half a pi, and this is our x. See, the same x here is the same x being used here, and that x is the one which we subtracted half a pi. So here I want to grab this, and we need a modulus node. Modulus, and we grab that x value, such, and then I wanted pi times 2 as my other input to the modulus node. So x, and then the comma separates the two inputs, and that's two arguments, and then pi times 2. And then the result of the modulus should be divided by pi. Now if you want to be more efficient about this, I might not end up doing this because I like actually being able to show that it's pi here. But you could first pre-calculate 1 divided by pi. So the reason for that is when you're doing shaders, it's more efficient performance-wise to do a multiply operation rather than a division. And instead of dividing by pi here, I could instead do 1 divided by pi and use that as a multiplier value. So that is, instead of dividing by pi, I could remove the division here. I could multiply by this value instead. And then I end up using a multiply instead of a division, which is more efficient. But I'll just go along with this. I wanted to mention that though. So divide by pi. Got my pi here. Divide. Plug that in here. And then lastly, I'm now done with everything inside here. I'll need to use a floor node in order to round it down to just get the fractional part all the time. Get the full integer value. So floor, and then the result of that division operation should be what I am flooring. Such. And I think I might just set this up here instead. So first, when it's expanding, when it's contracting, and this is going to be my mask which chooses between these two. And in order to do that, I could actually use a if-else basic node. You might think to yourself that you could use a lerp, and you're absolutely right that you could use a lerp, because the lerp is going to take one value, a second value, and then shift based on the mix. But this one does it in a more expensive manner, I believe, since this one can actually handle that gradual blend between these if you wanted 40-60 split or something. Whereas if-else basic will just do a hard swap between one source and the other source. That's totally fine, because since the point where I want to switch between these it's at the very top, and they sync perfectly here. So if I keep the blue and then very abruptly cut and use the green, you're not going to notice it since they are at exactly the same point. And I do have this, my mask if you will, syncing up perfectly at that very point where they meet up perfectly. So I should be good with just using a if-else basic in this case. So the condition then will take a true or false. Notice as this is a bool input, and bool is either true or false, like an on-off switch, if you will. And I know that my output here is going to output the purple one is going to output just 0, 1, 0, 1, 0, 1. So this is actually a perfect candidate, I think, for using a on-off behavior. Problem is this is a float, and this one accepts a bool. Luckily, there's a way to cast these as between them. So if I go type float, you'll see that I have a float to a bool, which will allow me to convert this value into this data type, which just feeds true or false, with which the if-else basic is expecting. Now, the true value is going to correspond to the value which is at when the bool value is at 1. So that is, this value is going to be my true value. And for that value, I wanted to have the sine result which has the power operator. So the power operator result should be the true, and the other one should be false. So the true should be my power result, this one. This other one, the expanding, should be my false. Then this is now going to be my new result, which goes in here. Right, so let's see if we're lucky enough to get this correct on the first try. So I've got these. I would need to set that exponent value to be something other than 1, otherwise I'd see no change as such. And then let's hit play. Yes, it does seem more forceful if you ask me. If I set this to 1, see that now I have the more smooth, it's expanding and contracting with the same kind of force or momentum, if you will. And if I set this to a really high value, you'll see that the contraction is now very harsh. If you have a look at one point in the silhouette, say over here, you see that when it's contracting, it's doing that more forcefully. And the higher I set this value, the more forcefully. So now it's almost unrealistically fast when it contracts, like hitting really hard. But just a value of around, say, 5 or something, I think is enough, because it just shifts the feeling of speed or momentum to not have the same kind of movement speed all the way throughout the animation, which looks a bit boring. So I think that should be it. Last step, of course, is that you might want to just play around with the tidying up here a bit. Not that you have that many options in terms of commenting or organizing, but you can at least move them around and try to group them together to lay them in a more logical manner. You could also go ahead and group them together if you wanted to take the time and do that. Yeah, I think one good takeaway from this is Sine is your friend when it comes to vertex animation, especially if you want a looping type of animation. Since Sine will always go from -1 to 1, you're basically hitting back at your starting point within one cycle, and then it just keeps repeating. So oftentimes it can be very beneficial to just drive an animation based on Sine. Yep, so I hope this has been useful. Thanks, guys.